Hi and welcome. This is part 2 of a video series documenting my journey to build a stationary storage for my home using a 24 kilowatt hour Nissan Leaf battery and a Fronius Gen 24 Simo inverter. To keep this video reasonably short and to break down the video series into smaller segments, today we will focus on building a step-down box. What this means is basically making a DC junction box with fuses and oversurge protection, and basically to be able to shrink the cabling from very thick 50 mil orange high voltage cabling down to 10 mil wiring for the Fronius inverter. Yeah, and probably it's a good idea to do a small disclaimer. I am by no means an expert in any of this, working on metal or wood or electronics, and it's just a do-it-yourself hobby project and a new learning experience for me. So please don't take this as a step-by-step guides. There are more better videos and instructions for that, but rather learn from my mistakes, and please feel free to comment down below if you have any suggestions on how I could improve my next build. After getting the battery for stationary storage, I had to basically do 4 things. Replace my inverter, solar inverter, with a hybrid model which supports external battery, then install a energy meter, and then set up the LilyGo board to act as a gateway between the Fronius inverter and the Nissan Leaf battery. And the 4th step is to set up the physical cabling between the high voltage battery and the Fronius inverter. Arguably the most expensive component in building a stationary storage is the battery, and I happen to have a spare battery after upgrading 40 kilowatt hour battery to my daily driver Nissan Leaf. Majority of the cost of my build was from the Fronius hybrid inverter and some miscellaneous equipment bought from AliExpress. Therefore I was able to keep the cost of my build relatively low, costing me a little bit over 2000 euros total. Metal box seen in the video was originally used for storing an optic scope for a heavy recoilless anti-tank weapon used by the Finnish army. In Finnish it is called Raskas Sinko and nickname Musti or the Mutt. Here's a picture from a Finnish museum with ammunition for the weapon, and the optic scope can be seen on the top left corner, and the box same that I have is on the lower left corner. I used this picture as inspiration for my build, and instead of grey plain plastic generic box, I chose something else instead. I start off by removing all of the wooden parts inside of the box and drill holes for the orange thick high voltage cables. To secure the high voltage cable in place, I use cable glands on the holes. There's a paper note on the cover of the metal box with some instructions on how to use the optic scope. That's a funny little detail I wanted to preserve for my own personal amusement. The alignment of the telescopic sight must be carried out on the weapon on a unit level before the weapon is used. That's what it says basically. Tähtäyskaukoputken kohdistus aseelle suoritettava joukko-osastossa ennen aseen käyttöä. Some while ago I picked up a building automation control panel in a metal enclosure, as well as a main electrical distribution board from a local electrical waste dumpster. I guess they had been disassembled from a demolished building and thrown away. And stuff like this can be very useful, like DIN rails, DIN rail spacers, terminal blocks, AC fuses, and even some cables can be reused after visual inspection and simple testing. To give you an overview what can be seen in this picture from left to right basically is on the left side there's a DC fuse holder, and you can open the slot and put a high voltage DC fuse inside, so in case there's a problem the fuse will pop and hopefully won't break anything. On the center there's a terminal block. The big hole is for the high voltage cables, and from there there's cables going to oversurge protection on the right side, as well as the DC fuses on the left side. And from the DC fuses there's a cable going out to the inverter eventually, however not connected in this picture. Yellow-green cables are for grounding. One is connected to the box using a crimp-on lug, and the second one is connected to oversurge protection. Initially I thought I would use one cable, but it was kind of a tight spot, so I ended up using two grounding cables. When connecting the high voltage terminals to my Nissan Leaf battery, I noticed I had generated a problem for myself. Originally I had a minus terminal on the left and a plus terminal on the right, and that caused some cable tension, and the high voltage cables did not go directly but were twisted, causing additional cable tension. So I decided to redo it and organize the terminals as seen on this picture. So on the final one I had plus terminal on the left and the minus terminal on the right, and that made it possible to have the high voltage cables go directly without any tension. When working with electronics and especially high voltage, it is absolutely crucial to have a good conductivity and double check and triple check that the cables are connected all the way and tight, and they are not loose, because if there are loose connections that might cause heat and even a fire in the worst case. So that's something to keep in mind. At some point I will make a shopping list if you are building a similar kind of a setup, so that it is easy to purchase items from AliExpress. You might be able to source the items locally, but I think AliExpress is a good alternative. The delivery takes a few weeks, but in my own project and many other people's project, I have not really seen any quality issues much. On top right corner there's a cable gland with a grounding cable going to the oversurge protection. Originally the idea was to ground the chassis using the same cable, and that original grounding cable going to the chassis can be seen below the cable gland, but I end up removing that. Might not be the prettiest, but I'm fairly happy with the outcome, and I've had the battery emulator up and running for several weeks now, and the software and hardware is definitely stable. Not a prototype, but there are hundreds, if not thousands, of installations around the world using the same basic principle of utilizing an EV battery for energy storage purposes. And I bet this is something that we will see more and more in the future. If you are an engineer-minded, do-it-yourself kind of a tinkerer and have accessibility to a second-hand EV battery, this might be a good alternative for a commercial energy storage solution. The battery was too close to the wall and I was unable to get a good connection to the orange high voltage cable and step down box. So I had to use a jack to move the battery a few centimeters away from the wall. I decided to place all of the non-high voltage components in a separate metal enclosure to avoid electrical interference and for safety reasons. The red metal box in front of me contains a LilyGo board, a terminal block and all of the necessary equipment for a solid state relay automated contactor control. More on that on next episode. Thanks for watching if you made it this far, and see you on the next one. Bye.